Okay, let's let's go really early. We've had a number. Noah had a number of questions and good ones about the gravity model that we were. This is problem 4, and this is the half graben. Everybody got the geometry of the model from the words. Anybody have a problem with what the picture looked like, the model that we were supposed to input into the gravity survey? So a half graben means basically there's part of the earth that has a graben in it, okay, where there's sediment fill. What could that be due to? Well, it could be a normal fault, right? There could be a normal fault along here, and the sediment basically fills in the low spots, preferentially to the high spots. At some point, there's deposition above here that covers the entire granite or the entire geology below that. What's an example of this? Anybody know? Pardon? A ditch. What could be another example? Well, when you look at basins, regional basins across the country, this kind of situation, maybe not perfectly, but happens a lot. And so when you're prospecting, for example, for oil and gas, you may need to look for an area like this that has a deeper sediment profile than granite. You're probably not going to find a lot of oil and gas in granite, but you may find a lot of oil and gas in these gravels. An example of that is down in West Texas, New Mexico. Right here, there's something called the Midland Arch that comes through here. And this arch has a similar geometry. Basically looks like this. And basement is high in this area, and then sediments kind of come from the side here. And these sediments are where we have very, very large oil and gas deposits. So understanding basement structure is actually critical for oil and gas exploration. And gravity is a pretty nice way of getting regional estimates of where the basins are and where they aren't. So I guess the question was, why this model? Okay, why do we have to put rectangles in? Why can't we put different models in? And what I'd like you to think about here, when you think about this model, so let's say that we have gravity surveys points like this, all the way to there. Now remember when we talked about the non-uniqueness of gravity, what we said was that as we go deeper, we're not able to resolve lateral changes as easily as if we look shallow. So what does resolution really mean? Okay, when I'm trying to resolve one feature from another, what am I looking at? I mean, if you're trying to resolve at a distance, let's say you're watching a football game, and you're trying to see which number it is that day. I don't know about you, but as I get farther and farther from the field, I can't focus as well, right? And the numbers get fuzzy, right? And when they get fuzzy, I can't tell whether it's a 3 or an 8, for instance, right? And the 3 kind of is fuzzy, right? It's basically not a sharp 3, it's fuzzy. So when I talk about fuzzy, what am I talking about there? What am I doing to that model when I fuzz it up? Anybody have any idea? I mean, that's a sharp model, right? I'd be right next to that when I look at it. Well, if I fuzzed it up, what I'd probably do is, rather than this kind of model, I'd have a smooth transition, right? Or maybe it would look something like this, right? This would be the transition that I see, and And obviously I'd have a transition this way too. And I'd have a transition here, maybe sharper, right, because it's shallower. But I'd smooth this model out. It would become pleasant. So what are we doing when we smooth a model? So what we're essentially doing is saying this is what gravity detects. It doesn't detect the actual model. It detects a smooth version of the model. So you can think of perfect model through some kind of smoother, quote unquote, to get gravity model observed. So when we think about the gravity data that we collect, remember we're not able to resolve one model versus another in many cases. We can't tell the difference between whether that's a smooth version or a sharp version, right? How do we just basically decide whether a number's what the number is? Well, we make an assumption that a football player is wearing a number, right? He's wearing the number 3. What if it's a different design? Well, we didn't know they were numbers. Well, we kind of guessed something else, right? Some shape. Maybe it'd be a letter. Maybe it'd be the letter E. Same thing in gravity. We're not able to really tell what the true subsurface model is, so we have to make an assumption that this is the idealized model rather than some smooth version. And what do we do to make that assumption? What kind of other information? How do I make the assumption that it's not smooth, that the real Earth is not smooth? But the only thing that I can see in gravity data, it's like looking at the football player. All I can see is the smooth version. It's pleasant version. That's all that gravity gives me. So how do I make you believe that the Earth is like this? And what are we doing there? We're using the geo to basically bring in our geological information. So that's why we're able to hypothesize this model, but we know that gravity is never unique, and that in reality what we're going to see is some smooth version of this model. So the answer to your question is whether you want it to, right? You could put either model in and you get the same result. So you're not limited to these polygons. And you could do other things, right? You don't have to have a smooth version, or you don't have to have this thing in here. You could have some undulating surface, right? As long as it averages out to the same thing, how are you going to tell the difference? You're not. But the undulations, if you smooth the undulations out and you get a straight line, you're going to get the same gravity. So smoothing is a huge part of any geophysical technique, particularly gravity and magnetics, which are low resolution potential. And we talked about what the smoother was before. Remember, the further we are away from a gravity anomaly, the more smoothing is going to happen. So what is smoothing? When I talk about smoothing, what am I talking about? The easiest way that I can think about that, is, because this depresses me so much, I'm going to look at what, Chevron stock price? Like that? Okay? And there are little bumps some jiggles in there. And you probably have all heard in Squawk on the Street or something like that about a 50-day moving average, right, versus an instantaneous value for the stock price. Let's go at the instantaneous value. I'll basically do. Okay, that's the instantaneous value of the stock price. The 50-day moving average may look like something like this, right? So this is basically taking a point here and averaging in all these points around here. So it's saying the value here, VI, is equal to sum from